had them in this order? How many of you did it a different way? So these are the problems when I go over to page 8. There are 2 problems for you to do. Just write from least to greatest, and then copy the numbers down, and then see if you can get them in order. As you're doing this, be sure to think of what strategy are you using. If you need to write some things down to help you remember, or how are you solving this problem? How are you supporting your answer? Okay, I'll give you another minute and then we'll share with our partners, have a little discussion of what you came up with.
The old school was like the teacher would tell the strategy, this is how you would do the problem, and then you would do it. Well, some of the students have come up with other ideas that work, other strategies that work, other plans, and they can come up with the answer.
So then it's 0.25. But then what about
Okay, what you get for me?
the
25%.
So if they share the different strategies or try to come up with them, maybe the person next to them says, oh, that's what it means. You know, she said it this way, I'm hearing it another way now, and maybe that's what makes sense to them. So we're trying to put out there as many different ways of doing a problem, because maybe because of their prior knowledge, something that they can make a connection with, and maybe it's not the example that I would have given. So we try to get different examples from different students.
So Keith, what did you do? Do you want to come up and show us? Okay, let's see what he did.
I drew pictures and I figured out that 1/2 was the biggest and 1/9 was the smallest, and down here is the order, least to greatest.
Okay, let's clap 3. Ready? 1, 2, 3. Another way. I still heard some other ways. Does somebody have a different way? Alicia.
I saw that there were all ones, and I knew if the bigger number, the smaller piece. So I put the biggest number first, the denominator first, through the order they were in.
She says that if the denominator is a big number, then it's going to be a smaller piece. Okay? Why could you do that? Why did you just say, well, 9's is a bigger number, so the pieces are going to be smaller? What made that work? Do you know? Okay, let's see if LaQuoya has an idea.
Has the numerator with 1.
Look at all these numerators. What are they?
Ones.
It's just easier to compare the fractions if all the numerators are the same. Or what did we find when we got to problem number 2? What did you do with your fractions?
I just drew 2 rectangles, and I made one into 4 equal parts and the other one into 8 equal parts, and then so I shaded in 4 8ths and 3/4.
Okay, and which one's bigger according to your drawings?
3/4.
3/4. What are some ways that we can compare fractions? Just from our discussion, what did you hear? What's one way?
Fraction strips.
Fraction strips, okay? What's another way? Equivalent fractions. So we can get equivalent fractions.
Drawing pictures.
Pictures. Okay, what was another one? You did something, Alexi. Yes. Remember this? Oh, did you erase it?
Yeah.
Oh, Alexi, it was such a brilliant thought. Do you remember what it was?
Yep.
You just look at your paper. You changed all the fractions to percents. Will that work? Yeah. Yes. Change fractions to percent. So if we could change them to percent, Shayla's thinking. Decimals, what about them?
You can change the fraction to decimals.
You could change them to decimals. Wow, good thinking. So now when Mrs. Fazio gives you a problem like this, look at all the different ways you've got to figure it out.
So we tried to get different examples from different students, and hopefully they can, tap into at least one of those. But if they've only got one way to get there, their chances of success are not as great as having more than one approach.
You need those fraction pieces. Remember when we cut up these fraction pieces? If you could pull those out, we're going to be using our fraction piece models, but we're going to be doing the build it, draw it, write it model. So we're going to build something with our fraction pieces, and then we're going to draw it, and then we're going to write about it.
The types of learners that we're dealing with in the classroom are the analytical, the visual, the auditory, and the kinesthetic. We have the ones that they just know it mathematically. They can just put the answer down. Some of them need to draw, and some of them are kinesthetic, so they need to be moving those things around.
How would you show me 2/5 plus 1/5? Does everybody have 2/5 and 1/5? Oh, look, can you go put that on the screen? Okay, oh, there you go. Okay, so do you have something that looks similar to that? Yes. Okay. Okay, so how would you draw that on your paper? Okay, so does this picture look like that picture? You had 2/5 and you added 1/5. Okay, so what would you write? You build it, you drew it, what would you write? What do you think?
2/5 plus 1/5 equals 3/5.
Okay.
Why I have them draw it and then write it is because I don't want them to think that we're just coming in here moving some things around. I want it to have some meaning. And so the meaning behind it would be if I can build it, and then if I draw it, what have I drawn? Because my construction is going to go away. So I want to remember what I drew and what the math is that goes with that particular problem.
Number 2, we have 4/8 plus 3/8. So build it. So it's 4/8. And the problem said to do what?
To have 4/8 and 3/8.
Okay, so where's your 4/8?
My 4/8 right here, and then my 3/8 right here.
Okay, so there they are. Okay, so put these kind of there they are and there they are. And now what were you saying about the half?
Well, I was just saying that 4 of these 8s is like 1/2.
Yes, what kind of fractions are those?
Those are equivalent fractions.
So you build the model out of the manipulative, and then you draw what you built, and then you write about what you built and drew.
Okay, so as you're putting things away, do your reflection piece. Victoria, was there reflection going on?
That the fraction, the denominator has to be the same when you're adding fractions.
Keep the denominators the same. What do you want to remember, Nick, about adding fractions?
The top number can be bigger.
What is it, Cheyenne? Improper. What is it?
Improper.
Improper. What do you want to remember about adding fractions? So, Keith.
Build it, draw it, and write it.
Okay, well, thanks for doing a great job. We'll see you tomorrow. Have a good day.